They always say you should never talk about yourself at a conference, but I think it's a good thing to do. So at least you know my background. I work for IBM. I'm a developer advocate. I work in the runtimes team, which is the team that produces Java. They're the guys that work on OpenJ9, which is the thing that we recently open sourced. I've been doing Java since, I would say, since before it was 1. So I was 0.99A or B, I think, was what I started with. So I have a lot of background in the VM side, a lot of background in the Java side, and I've also got some operational background as well. So it's the operational side that got me into learning more about cybercrime and cybersecurity, and that ended up with this talk. So this talk is about Java vulnerabilities. You hear the words, so I'm going to take you through some of the parts. We're going to talk about the boring bits, as it says, how the industry manages vulnerabilities. We're going to talk about something to do with, well, how a vulnerability is identified, managed, etc. We're going to talk about attack vectors, which is how people are trying to get into your system. It'll be very high level. We're going to cover the scary bits about cybercrime, at which point, if you want to leave and cry, I will quite understand, because it is scary. And then we'll do some code, so you'll get to see what a vulnerability looks like in code terms. Okay? So let's start with, what is a vulnerability? Bear with me. Right, okay. So what is a Java vulnerability? What does it look like? Here's your starter for 10. Here's a git diff, well, it's just a diff. And you can see circled a little change. 2 characters, okay? To call it 1, right? This fixed a bug. It fixed this little bug. The Java math double parse double. If you gave parse double a particular number, the one that you see there, and you ran Java math double parse double with that string, with that number, your code would never come back. It would loop forever, infinite loop. And this thing was reported in, it says 2001, and people went, eh. So it's an interesting little thing. So what? It's a corner case. But it turned out not to be a corner case. Because if I can get your code to spin, I can create a denial of service attack. I can stop your server. And it turned out that if you had some HTTP headers that had floating point numbers in them, and you were running a Java app server, at some point these would come together, and your Java server would stop, because as part of parsing the header, which says that I expect a double, it does converts it, calls that routine, your system hangs. Right? That was really cool. And this got rediscovered in 2011, and there's the URL, you can go read all about it. What it really meant was that we had this very long period where servers were being hung left, right, and centre, because everybody understood how easy it was to use curl or something and to set some headers and include a double and just try it with servers, right? They were hanging servers left, right, and centre, right? And this was really perhaps the start of all this, when people began to realise just how vulnerabilities could be exploited, and how what we considered to be silly code was suddenly not silly and actually had bigger consequences. So the first thing you can put on your list about what a vulnerability is it's a bug, because obviously it was a bug, but it can be exploited by an attacker. So that's our first set. Okay, Java vulnerabilities, bugs that can be exploited. So let's think about how they exploit you. Right, so they can attack your availability. So that's I can bring your system to its knees. I can cause you to crash, so you have to restart. I cause you to crash, you have to restart. Or I can cause you to hang, and those sorts of things. So that's an exploit, right? They're not even trying to steal stuff. They're just trying to bring your system to its knees, possibly to try and extort some money from you. Right? Sometimes it's Well, somebody's paid somebody to have a go at their competitor and bring their system down, right? It's that sort of activity. So they can exploits can reduce your integrity, which means they can get into your system and change your data, they can change your code. Okay, that makes sense, that's another way of doing it. And obviously breach confidentiality, steal your data. Get in, get access to things they weren't meant to have access to. Right? And I think that all makes reasonable sense. The one that we've added to the list recently is Bitcoin mining. What? Yes, so imagine that you're connecting to a Wi-Fi gateway and you get the constraint pop up, you know, you're in a hotel or something, a little thing pops up. What there are exploits out there that not even exploits really, they just use the fact that you've got a browser open, even if it's a constrained one, to use your CPU to do Bitcoin mining. Wow, and then you log onto the web browser, onto the gateway, and it goes away. And that concept of stealing your CPU is becoming more prevalent. People are finding out ways to get exploits, not to attack your system in terms of trying to put exploits into the system and change your code, but actually just try and steal your CPU. Right? So that's a new one. So as developers, why would you care? As a business, why would you care? You know? So there are exploits and there are people out there trying to make use of it. So how bad can it be? So now I'm going to talk through this cybercrime realities. Well, right? Level set so you understand just how big the challenge is. Right, the first thing you're going to have to think about is, do you think cybercriminalists are lone hackers? We all used to think about these guys doing it for kicks, doing it in their bedroom, 15 years old, you know, it's that sort of mentality, right? It's not quite true. And we also think, generally, that we would notice if we've been hacked, right? That you would notice if somebody had gotten into your system and changed your homepage and put, you know, owned by, you know, those sorts of things. Those sorts of days, they're still around, but that's not the big thing, right? And you probably think you're too smart to be suckered in, right? This is a nice little fish, one I got. I love this one. So I'm a winner of a brand new car, a $500,000, and an Apple laptop, which is obviously on a par with $500,000, right? You don't fall for these things, do you, right? One of the reasons that they're that simple is because the people they're targeting are people they want to fall for it. So if you are trying to extort some money out of people, you want to have the people who are the most gullible. So the bar is set very low. If you fall for that phishing email, hey, great. You can imagine that when they're targeting us as developers, it's nowhere near that obvious. So I should say, that organised crime is the biggest thing here. What people don't realise is that it isn't just people in their bedrooms doing this. It is groups of individuals, highly motivated, working together, right, to steal things. They are developers in their own rights. They use Agile. They go to conferences. They come to meetups and they learn things, right? So you can see the numbers. 2016, cybercrime was worth $450 billion. That's how much they reckon they were getting out of it. At the same time, the illicit drug trade was worth 435. So 2016, the cybercrime had just gone over the top of the drug trade. So guess which one has the least risk to the criminal? Which is growing the fastest? Okay. Which one is hardest to prosecute? How do you prosecute somebody for cybercrime? You've got to catch them first, right? It's easy to catch people with a truckload of drugs. It's very hard to catch cybercrime lists, right? And which of these is going to reach $2,100 billion, so $2 trillion by 2019, $6 trillion by 2021. Yeah, cybercrime. Let me put that out. Let me show you what that means so you can get the numbers. So red, cybercrime, green, the drug trade. There we go. Woof. The drug trade isn't expected to change very much in terms of how the value, but cybercrime is expected to go through the roof, right? And to put it in numbers again, $750 for everybody on the planet, or 13% of the world's GDP. That's how much money these guys are making, right? And a lot of it is down to the fact that we are letting them make that happen. Right? So this is why this is now important, because it's getting out of control. We have to do things. So you learning about Java vulnerabilities, even at the highest level, will help you begin to think about what you're going to do to start to tackle this. So let's carry on. Let's do some more tech. Another vulnerability. I have this directory, right? User spool foo space bar. Okay, you can tell I'm a Mac user, right? And I want to refer it to URL. So the obvious thing to do, file // and escape the space. So I've got a string. Okay, that's great. So if I write some code to create that, so there's the URL on the, okay, and I create a file, and I print out the file from this URL, the path, and I check to see if it exists. Okay. So if I run that, so there's the path, and obviously the exist is false because I don't really have that file. Because I don't have a file with %20, I have a file with space on the disk. Because I forgot to decode it. So I change my code, and I put I use a URI as well, and that means I can get the path, and that'll do the decoding. So when I run it again, hey, so I've got a path, and now I can check correctly that it exists, true or not. Okay. So you may go, oh, okay, who cares, right? But what happens if somebody had got into my system and created foo %20 bar on the file system? Right. Then this test would have passed. Okay. Not a big deal? Okay. On Windows, for example, anybody can create root directory. Anybody's allowed to. It's a design feature. So I can get access to your system, even if I don't have limited privileges, I can still create that root directory. Okay? Okay? Not a big deal? Okay. Imagine this. You've got an extensions path, or a class path, or any of those wonderful directory lists that we use in Java, and there's a possibility that on that path will be things that don't exist. A common one will be something that looks like that, where you've had, say on Windows, somebody's installed some application and it's got some Java componentry to it, okay, and maybe they've got an optional part that isn't installed, but it doesn't matter because the JVM is going to ignore it because it doesn't exist, okay? So you've now got a class path or an extensions path that's got an entry that doesn't exist, okay? So what that means is that I might be able, if I get on the system and create it, I am now able to insert code that you could be looking for ahead of where you normally found it. Okay? And that's sort of what happened, right? There was a sort of bug in the VM, right? So if the JVM doesn't do the decoding, okay, then that means that if somebody creates that directory in your extensions path, they can insert code, run DLLs, and if it's classes, it could be a jar file with code in that replaces the code that you're running, right? All because of that one line, right? So that's not quite the code that we're talking about, but that's sort of an example of how it could have been, right? What I want you to take away from this is that's what vulnerabilities always are. They're almost always very simple things, right? Now, no smoking guns or no big things or big comments saying we should fix this, it's a big security hole. No, there are probably some of those. It is little tiny things that the guys join together to create those big exploits. And it's just not code. We get exploited too as developers. We are very, very poor at dealing with security matters. Right? We ignore them so often. Right? We are targeted because we know how the code works, that's for sure. Right? We're targeted because we write the code. We're targeted because we tend to have higher privileges than anybody else. Right? And we are over-trusting. We'll come on to that. Right? We use other people's code without inspection. How many people here have downloaded code from the web? Okay, right. Okay, so how many of you have done something like you've changed a Maven POM or maybe a package on NPM? You've added something in for open source. Yes, you've all done that. Right? The chances are that maybe you checked out the license of that thing that you're going to use. Maybe your company or yourself has gone off and said, what license is that being used under? But I'll bet you never went and checked what its dependencies had. And I bet you never went and had a look at who wrote that code and determined whether or not you felt they were trustworthy. We don't do that, right? And in some circumstances, it's very easy for the bad guys to get in there, right? And you just take code that you trust because, hey, I went to, Stack Overflow and somebody said I should use this thing. And so I've done that and it works. Right? Good source of getting bad code into your application is to give you some help solving a problem, and then you don't do any more with it, right? Because we just use this stuff. Right? That's us. Bad guys, proud, the weak, vulnerable, ignorant. That's us, right? And I have this conversation with people, and they go, no, I know all about it. And I go, okay, have you ever done this? You ever Googled for getting Java to accept all certificates over HTTPS? Yes. How to trust an SSL certificate? Yes. Have you ever Googled for very trusting trust manager? Right? I bet you, one variation or another, you've done this. You've gone looking for, how do I turn off certificate testing? Right? We just do it because it's the easiest option. How many have written something like this? Okay, I have. Yes, everybody's, okay. So it's a trust manager. So if you haven't done one of this, then either it's because you're very good to understand why it's a bad thing, or you never had the need to do so. But it's a piece of Java code, right, that you can use to override the trust manager when you are pulling code down from the web, right? And basically it says, is the client trusted? Is the server trusted? And the answer is always yes. There's no checking going on, which is what you would expect in an normal code. Right? So we all do this. We do it all the time, right? And do you want to know how bad it can be? Well, I did this. I did a GitHub search for Implements Trust Manager because I thought, let's go see what people write. This is what I got. This number's about a month old, I think. 103,000 hits. You know, a very friendly, accepting trust manager factory allows anything through, right? All trusting cert request, a very trusting trust manager that accepts anything. And it may sound funny, but a lot of this stuff is in open source that you're using. Some of this stuff is being shipped in the modules that you're consuming. Because it's just like, well, okay, I'm going to use module A because it solves my problem, but actually these guys have done something really bad. Right? Bear that in mind, right? Because that's code that you've got on your part. Okay. So effectively, that means you can add to your list of what's a vulnerability to be, it's a bug, but it's also a feature. It's something we designed in that it's going to get exploited. And these guys are, the bad guys are out after these vulnerabilities all the time. There is an arms race going on. The guys with white hats are trying to find the vulnerabilities using the same tools and the same level of ingenuity as the black hat guys are doing. The black hat guys are more incented because they make a lot more money than the other guys do, right? But you need to understand this isn't a quiet thing. There's a large amount of money involved. There are many people doing it and out to find these vulnerabilities. Okay. Right, so I promised there would be some boring stuff. So I'm going to do the boring stuff and then we'll come back to some code. While you think about all your bad actions. So we're going to talk about this, the process of managing vulnerabilities. Okay? So, the good news is that there are common ways of managing vulnerabilities. We talk about them, they're called CVEs. And CVEs is a common term for vulnerabilities in any piece of software. Right? And it's useful because it means we can talk about a particular vulnerability with a number rather than going, oh, that one which was, well, we could do X, Y, Z. They get a number. And so we can track it. So you could go see whether or not the problem is fixed on any particular dependency. And you go to the website and you can do some nice searching and you can get lists. Again, this is a month old, I think. You can search for all sorts of things. So one of this is Java, and the other one, I think, on the one on the left, no, the one on the right. One on the left, sorry. The small one is Java and Java serialization, right? So there's always hits. And if you look at them, they look like this. Right? Lots of nice words that don't really tell you very much. Right? So if you look at one in Overflow, okay, unspecified vulnerabilities. Right? Here's the horrible bit. We're not going to tell you anything about the content of vulnerability. We're going to try very hard not to give you any clues unless it's really necessary. Okay? So you get words like this. It says there are bad things that could happen if you don't put this fix on. Right? We won't tell you any more. And the reason we won't do that is because it's the moral equivalent of tweeting credit card details and PIN numbers. You wouldn't do that, because if I did that, what would happen? Somebody would come and empty my bank account. So if I give you details of Java vulnerabilities, in detail, I'm basically telling the bad guys, hey, here you are, here's a plate. You know, it's got everything on it. So what we do is we score everything. There are these CVSS scoring system, which is a complex process of trying to work out how important it is for you to have this fix. Okay, and you can see all sorts of columns and stuff. Okay, right, and there's all sorts of stuff. But the important bit to take note is there's also a temporal component. These scores change as people revisit it and understand that there may be other consequences they hadn't thought about. So you end up with this wonderful vector which tells you what the attack vector is, how complex it is, do you need privileges, etc. Right? You can read all the words. Right? The net is it comes with a number, high score, low score, and we say, hey guys, this is a really important thing, go fix it. Right? And we do that, so Oracle does it, IBM does it, everybody's got products, has some process. As Java, you can go see the Oracle CPU advisories, there's a little matrix that tells you how important it is. And then IBM's got the same because we have our own product bulletins. It's all sharing with you information about these CVEs in those numbers and priority terms. Right? And it's up to you to work out whether you should fix it. Right? Now, if you're lucky enough, or unlucky enough, maybe we all discover one. That'd be cool. So what do you do if you discover a bug, a vulnerability? Well, report it responsibly. So there are places where you can go to, Oracle, IBM, it's very straightforward. You can go report it, say, I think this is a vulnerability, right? And we would really encourage you to do so, right? We would encourage you not to shout about it, because lots of people do that. Hey, I found a vulnerability. That's not a good idea, right? Don't publish it, as it says, don't tweet about it. Don't go, hey, I found a bug, and you post it on a forum. Just don't do that, because you're just giving it away, right? And please don't sell it. I'm not sure that's really incentive for me to say don't sell it, because if you're that way inclined, you're just going to do it anyway, right? But if you think it could be a one-line thing, I'm not really sure about that, just report it. Because already we've explained that vulnerabilities are small things, not big things. Right? If you think there's a weakness, report it. That's the best thing to do. Right? And then once we've actually got the fixes, so we've got a vulnerability, and we've got to fix it. Well, we've got the CVS scoring to tell us the importance. And obviously we're going to try to fix as possible, but we need to understand that fixes don't always happen instantaneously because we have so many human beings to do this. So we'll do it by score, we'll do it by what resources we've got, we'll also do it by whether or not somebody is threatening to disclose it. White hat guys who will find bugs, find vulnerabilities and report them, normally puts some sort of time limit because they want it addressed. And if it doesn't get addressed, they threaten to publish it. So we have those things as well. Right? The point is, we have regular updates. If there's a fix in the regular update, then you know it's a regular update. If we give you one that's out of band, that means it's really important. So pay really big attention and get it applied. Now, this is where it starts to get a bit strange, because what we would say to you is, have a look at the CV, the vulnerability, and assess whether you think it's going to be impactful. Right? If you don't use JAX-P, for instance, you might go, I don't need to apply it. Why would you destabilize your product for a fix if you don't use the stuff that we're fixing? Right? And you can do these things, so you can go have a look and assess this. But the trouble is, we don't actually know what dependencies are. So the trouble is that what I find when I have these conversations is, you don't know what your code does. Well, you know what your code does, but you go, well, I use these modules and these modules and these modules, and you go, that's cool. What do those modules use? What do those modules use? And you find that actually a lot of these vulnerabilities are using something that you wouldn't even imagine some particular component you have in your tree is actually using. Right? So one of the things that you have to do is get so much better to understand what your dependencies are and what they use. Because if you don't have your head around that, you don't know whether you should be applying these things. Okay? Right, so let's talk about attacking. Attack vectors, which is a nice name for saying what are the categories of how people actually get to you. Right. So there are things like untrusted code. So what does that mean? It's like, can I get code into your system? Right? Can I find code on your system that I can call? Right? Working around the security manager is always a classic one. And the interesting thing is, you don't know that you've got these because it could be anywhere. So what the bad guys will be doing is looking at the code you're using and looking for places. You've got some vulnerabilities in your code. You've got class path, you've got a version of something installed. If I can get hold of that information, I can use that to assess that you've got code in your system that's got a vulnerability in it, and I can work around it. And one of those is, can I get around your security manager? Okay. So that's one type. Then the plugin in Webstar has its own attack vector, because we had so many bugs in plugin in Webstar. It just gained as like, well, it's a way of getting problems in. You know, it wasn't very well designed, and as a consequence of that, with all sorts of ways that it could be exploited. And unfortunately, as you know, we had a period where everybody was using Java plugin to do nice little UI stuff, and Webstar and things like that, and of course it just turned out to be the wrong thing to do because of all the security stuff. Good news is, as of Java 9 is now deprecated. That doesn't mean it's going to go away anytime soon, but at least we hope that people won't keep using it. Now the biggest source of attacks, of exploiting a vulnerability, is this, untrusted data. Right? This is where you are not validating the data that comes in. Right? So there are lots of places where you could either do it yourself, or there might be some code you're calling, where information comes in and it's been crafted in such a way that it will drive your code in different ways. Right? And we've got a couple of examples of that. Right? But you can see it's basically SOAP calls, XML calls, here's some JSON stuff. Here's an SQL injection where I'm basically sending you a string that you're going to send to your database, and I've figured out that I can now insert some extra statements because you made that possible. Right? If you don't validate the data that comes in from the server, from the client, you are vulnerable all the time to getting untrusted data in. So if you do one thing out of all this is you go back and look at all the data you're coming in, and you go, what am I doing to ensure that it's absolutely what I expect and there's no opportunity for it to be subverted, right? But you bear in mind that it's not just text. Here's a nice little bug. This is an image of a cat. It turned out there was a vulnerability in the OpenJPEG code, and the right people figured this out. It was buffer overflow, which basically meant I can send you some an image with some extra stuff attached, the pirate payload, and that would end up getting set into memory and then it would get executed. Right? So even the images that you upload need to be validated. Right? And by the way, there are lots of systems where they ask you to upload images, right, where they may say, they may put maybe a size limit on, but most of them don't actually check it because it's easier not to. And if you have systems where you say upload an image and you don't check it, that's a denial of service opportunity, because I could just start sending very, very large images. So if you say I want a 2 meg image of your photo, please, and I've got a nicely crafted mega image of gigabytes, I can bring your system down because you're just gobbling up all the bytes I'm sending. So here's one a bit more real. So there are 2 bits to look at. The top bit is a version of a payload, right? You can go read all about this one. So you see there's, imagine this is if you're going to post to a website and you've got content type, which is the standard header, and there's some gobbledygook in there, which we'll come to in a sec. And the bottom bit is just talking about Apache struts and some logic that it's got. So what happens is, this payload comes in, and Apache struts just basically says, has it got, it's a content type, so I know I've got the content type, so I need to do something with it. I take all that GORP, and I scan it for multi-part / form - data. Hey, yes, it contains that string. Great. So it then tries to parse it, because it thinks it should be form data format, but what it finds out is that it isn't. It isn't form data, right? And what it tries to do instead is it tries to parse it. It's not the right form. So what is it trying to do? Well, it asks Apache struts, says, okay, well, I need to tell you this is wrong. And as part of that process of reporting that the data is in the wrong format, this stuff gets executed. Because this stuff is actually in this scripting format called OGNL, which comes from struts. So this is actually script. And if you look closely, you can see what it does. Right? It does Java lang runtime, get runtime, .exec. Could be anything. Right? All I have to do is find somebody who's got the right version of Apache struts on their website, and post this data. And I can make that server do whatever I want. Anybody have a clue where this might have been recently used? Way! Hey, excellent. I did this talk recently, and it turned out one of the Equifax guys was there, and he came to me, and I said, did I do it right? He said, yeah. Right. The really scary thing is that there are still thousands and thousands and thousands of servers out there that use Apache struts with that vulnerability in. Right? People haven't got the message. What did we get out of this? What we got was, we didn't validate the data, right? Because then we should have said, well, we shouldn't execute this because it's wrong. But somehow we went off and executed it, right? We went off, and that was really weird. And that was probably trying to be helpful. So you can add to your list, and again we'll talk about it, is the way that you deal with failure can be seen as an exploit. So there are other types of attack vectors to put onto the list. Cryptographic things, so there are 2 types really. There are protocol flaws, which is where we go, oh dear, we've realized that this particular protocol design has a weakness, and they get nice names. And then there are implementation things, which is basically a vulnerability. They don't get nice names, right? But it's good to understand that even some of our most important layers and API designs can have vulnerabilities in the design. Right? And as you can imagine, depending on what the problem is, well, lots of things go wrong. If your encryption is broken, then I can steal all your data, right? Which is really, really good. Or maybe I can just steal your private keys. One or 2 of these flaws is just basically going, I can get your key. Once I get your key, I can be you. Right? And then there's the last one, which is about local. These ones will always say this is an attack vector where you have to be on the machine to make use of the exploit, right? And you can see like getting access to sensitive data. If I can get onto your system and I can be you, well then I can do whatever you can do, right? It's also a way, of course, of planting in code. So it's not just stealing stuff. It's the ability of me to actually add in vulnerabilities of all sorts of malicious code, malware, whatever. Okay, so that's local attacks. They don't normally get a very high CVS score because the assumption is that it's really hard to get local access. And so you might think that you're not vulnerable to that because you have good policies and you say, no, it's fine, there's nobody can actually get onto my system. Well, that's what everybody thinks. And then they get one of these. And we want to guess what this is? Recent. So, if you've got one of these, then you've just had your hard drive encrypted, and somebody's offering you the opportunity to get it decrypted if you pay somebody some money. This was called Wannacry, which is lovely. In the UK, it had a lot of impact. Right? It brought all sorts of systems down. It brought the NHS got impacted, car manufacturers got impacted. Right? It hit 250,000 computers and climbing across the world. Right? And as I said, it encrypted your data and said, if you want it back, pay us some money. There were in fact two versions knocking around. There was the one where they would decrypt it for you, and the ones where they go, give us the money, thanks very much, oh, well, we can't decrypt it. Right? It turns out that somehow some journalists managed to have a conversation with the guys who did this, and they said it didn't go down very well for them because they didn't make much money out of it. And as it says, they reckon maybe $3 per every time machine, okay? Compared to the cost, which was a horrific impact, which is a bad thing in itself. My point is, if I can get that payload, right, Wannacry was installed on a different payload that I can go buy on the black market, I can go buy the payload, I can get code onto your system. You can let it in, your employees can let it in, your partners can let it in. So, let's do some more examples. Some of this is a bit esoteric. So, this is the most esoteric one, and I haven't got any pictures for this, but bear with me. Serialization in Java is fundamentally flawed. That's what you got to say. Okay, the design of it has a lot of flexibility. The problem is that flexibility can be really exploited. So basically, so how many here know they use serialization? Okay. So all of you who are Java programmers that have got some app server, if you don't think you use serialization, then you're probably wrong, because you can get opted into serialization. It's not you can't de-opt. And if you have stuff installed, you may find that you're being serialized and deserialized unexpectedly. Deserialization has the opportunities to change the data within your objects. And there are some nice, easy ways of doing that. And then there are slightly more complicated ways. But the main thing is if you, for instance, you have objects in your class, if you have fields that are object, then at some point the deserialization process will call a read object method. And at that point, it'll go to the serialization stream. So all your class has been, all your objects have been turned into a byte stream, and now you're pulling it back. And at some point, if you have an object in your instance, this read object method will be called as part of the serialization process. And then it will go to the byte stream and go, well, what object is coming up next? So what people do is they figure out how they can insert objects into your serialization stream, and then, because it's going to be code that in your system, it's no good just having the byte stream. You need to have the code. So what they'll be doing is they'll be looking through your class path and bearing in mind that I can get into your system, and I'll show you another way in a minute how I can get at your class path. If I can get at your class path, I can work out what you've got installed, and they create these things called gadget chains. Right? So these are people working very hard to build gadget chains, which are basically serialization constructors and deconstructors. They're looking for opportunities to insert into your serialization stream a read object, I put some data in that means you now instantiate something that you weren't expecting to do. You call the code calls something else, and maybe get to runtime exec or whatever, okay? Right. And you can see, Apache Commons had one of these in, and it was known for years that if you could get into the serialization stream, we could make that happen, right? And there's some stuff coming in to make it easier, less possible, but again, it's an example of a design problem that gets exploited. This is here just for fun, really. JDWP, which is the debug protocol. If you're doing Java debugging, client server, right, then you've got some protocol between the two. It isn't so much that JDWP has a vulnerability specifically, but if you've got debug access to a server, you have full control. You can touch anything, you can do whatever you want. What you shouldn't do, which is what a certain large bank did, was make the port that's the debug port available on the internet. Right. And some researcher found it, was scanning, oh, okay, yeah, I can connect, great, give me some money. And they paid up, I think. So be aware that it's not just coding mistakes, it could actually be operational behavior. Right, so I promised some more code. So this is a bit involved, so bear with me. So there's a line at the top, so here's a piece of code, helpful class loader. What it's going to do is help me turn a label into a class. So very often we have instances where we have data streams where we've got some processing that we want to do, and we've designed it to say, well, if the data stream says foo, then I need class foo. And you tend to have some sort of mapping. You see XML and JSON all over the place. I get data types. I want to be able to instantiate a handler for the data type. Okay, so this is a distillation of that. So I have a helpful class loader, and I put in two entries, a default one and a foo, okay? And you see that the properties file that I'm putting these in is backed by system.getProperties. And that's very useful, because that means that if I want to add things to this thing dynamically, or when the JVM starts, I can put a -d entry on the command line and register some new handler, okay? Because if it's not in my one, it'll fall through the system one and pick it up. That's really cool. Right, and then I have some code that basically says, given a particular handler, go off and try and instantiate the class, and tell me if it fails, right? Cool. So let's try running this. So there's the data at the top. You can see default and foo, right? So I'm going to have some code, and the first thing it does, you can see the sort of middle line, load class helpfully default. So I run that, and I get that. I get the class because foo string handler existed, gets instantiated. Good, magic. Then I try something else. So this is foo. Now, this foo class doesn't exist on my class point. So when I run it, I get a nice exception. And it says, class not found exception, could not find class for handler foo, cool, with value that. And that's useful, isn't it? Because when that fails, you've got some information about what the data was, so you can work out whether you got the handler wrong or the class name wrong. Okay, we all do those sorts of things. Okay. However, what happens if you do load class helpfully java.ext.dirs? And you get this. So that's silly. Okay, I've got all this extra stuff, but think about this. This is just an example of a handler, right, where it's doing this sort of thing. So what this allows me to do now, if I can control the handler name that comes in, right, then I can find ways of getting you to tell me, right, so I'm going to ask you, I'm going to give you a handler, and I'm going to say, give me the class for that. And of course it's going to fail, and you're going to give me back the data. So now I can walk through all your system properties, bit by bit. I can ask you, whatever it is, right, okay? So imagine if I could take that helpful code, and I've got the URL decoder stuff, and I've got the remote execution code, right? So I can deliver code onto your system. I can see what's on your class path, so I know what I can force you to execute. right? And I can look at your values. I've got all the tools I need to compromise your system, right? Just by being helpful. So that means to add to my list, developer rates. Right? We are so helpful, we help the bad guys by giving them information that makes it easier for them to break our system. Okay. So, that's all the bad news. The question is, to wrap this up, is, well, what could you do? What's available to you to start doing something differently? Okay, because you've got to start thinking more about security. You've got to start thinking about how you design systems. Right? So there are lots of categories of this coding practices. So CWE guys, there is large amounts of information about how you should design code. Right? And it's all sorts of examples. You'll see some here. Examples, this is C and Java. Right? Some of it you'll go, well, that's really stupid, but it helps you think about it. So don't hard code passwords. Yeah, okay. But there's a whole bunch of stuff in there you can go learn and look at. There's also what they call common weaknesses. Industry website, you go look at. Learn about the different ways that you can be exploited. The way that you commonly write code wrong or poorly. And you can see the list there. I don't know why they call it the 7 pernicious kingdoms, but you can see number 1, input validation. That's the one we always talk about. They reckon, the people I talk to reckon, 99% of problems would disappear if we just did good input validation. Right? It's because we let people in when we let them. Right? There are Oracle have secure coding guidelines for Java. Same sort of stuff. You can go learn about how you should do serialization. It's a bit drier. Okay, but the information is there for you to go read so that you can learn how not to do things. And there are tools out there. There are lots of tools. This is a really cool one. I was playing LGTM, it's called. Basically, take your Git repository on and connect it to this, and it'll start scanning and looking for patterns in your code and telling you that you may have a possible vulnerability. Okay. And then other ones like find security bugs. And these are just examples. There are lots out there. We don't use them, but it's worth looking. So if you use find bugs, is another one. And again, same thing, looking for code patterns. Right. And then I can point you at Owen, who's got a load of really good talks on the principles. So you can get a better education rather than just listening to me talk about how to fix some code. You do need to have an understanding from the top down, right? And he's got some really good ideas, helps you identify the risks that you're going to be taking. Because the question is, well, where do you start first? So everybody has a different answer to that based on what the business is. You can go to the OWASP guide. So OWASP publish their top 10 categories. It doesn't change that much. The top one is almost always, I think it's always been there, which is injection. I can get system. If you don't validate your data and you use some sort of database, the chances are that somebody can figure out how to inject, SQL injection or similar into your system. Right? These guys tell you what the problems are, what's the most important things. They help you understand how you're at risk. So, starting to wrap this up. So, there are some things that we can take away from this which are not particularly palatable. Number one is keeping your instances up to date. That means every time that we publish an update, you need to apply it. Because if you don't do that, then you've got automatically people know, right, that your system has that vulnerability. If you're at Java 8 point something and patches come out, then you don't apply them, then you automatically, we know. And how do we know? Well, because maybe I can get to your website, maybe your website will tell me that you're using Java 8, or that you're using a version of Struts or whatever, right? Websites can be quite useful, and they can tell you what software you're running. And there are tools out there, really, I've even got Java, I've even got browser plugins. You just come to a website, you press the button, it tells you what the system's got on it. Right? It's quite an eye-opener to understand how easy it is to understand that your website's running on, I don't know, IBM Lotus Domino, and it's using Ruby, and it's got this version of jQuery, right? We leak information, right? And these guys can find for that information, can find out what you've got installed. So if I know that you're back level, I automatically have a list of possible attack vectors. Don't have to work very hard because I know what vulnerabilities you've already got. Okay. Use the vulnerability scanning tools. There are loads around. There are people doing all sorts of interesting things. There are people making businesses out of creating the tools that we need to use to help figure out whether we've got vulnerabilities and our dependencies and our dependencies. If you're not using those tools in your CI process, then you're missing a trick. And there are things like, don't write stuff that other people have written, right? Don't write security managers, don't do trust security managers. Fix the problem, right? So don't work around it. Don't write your own custom crypto code. The number of people we've seen who've gone, oh, I just hashed it, and that's fine. They go, no. Right? People think that they can do better jobs. Right? If you want it to be secure, you've got to have a set of people who know what they're doing working together. We benefit from having large communities around particular important sets of code. Right? Don't write custom XML parsers. Okay? Don't write any custom stuff unless you really, really have to. Okay? I think most of it. Yeah. What can I say? It is in your hands. You are the guys who've got to make the change. You've got to keep compartment. You've got to keep current. The good news is some of this stuff we're already doing, like compartmentalization, taking your application and breaking it into small pieces. Well, if you're going down the microservices route, or even your serverless or stuff like that, you're already thinking about separation. So if you think about separation of your code, now start thinking about separation of responsibilities and who has access to these things, right? And thinking about those sorts of design, okay? Design for intrusion. Think about how is somebody going to get in and exploit my code, right? Penetration, learn about penetration testing. Go read the books. There's all sorts of interesting about how people get into your system, right? It's not rocket science, they just have a different point of view. And I think I've said most of this, right? Bottom line is, also remember that anything that you do to make your life easier, across the board when you're writing code. You remember there are times when you're writing some code and you're going, well, if I change it, it'll be more flexible. At that point, you think, how am I being too helpful? Should I figure out a different way of doing it? So I'm almost finished. I think you understand that there are a large number of people out making large amounts of money. And if your systems are vulnerable, and your systems are more vulnerable than the guy sitting next to you, you're going to get hacked. Right? And they're easy to find. They can get in from the front door, they can find out what you've got installed. You are totally vulnerable if you're not paying attention. So, as a plug for me and Simon, so at DevOps UK in May, I'm actually running a security workshop. It hasn't, they haven't published the agenda, but we're going to be doing it anyway. Right in Simon, who, as you may know, is now working for a security company, and he's going to help me with it, and other people as well. If you're interested, you'll come to DevOps, then remember it's there, and you can come and sign up and take part. And that is it. Thank you.